Hey, what's going on everybody? In this video, we are going to be going over how to square stock. The first thing you're going to want to do is head over to the material rack and find a piece of 6061 T6 aluminum. And all the critical dimensions on the print that we are going to need to square this stock up is circled in red. So we are concerned about these three dimensions, 3.5 inches, 2.5 inches, and the 725 thou thickness. So I'm gonna go ahead and measure the 3.5 inches in length, and I'm gonna go an extra 125 thousandths so that we have material to remove on both sides, so that we have a nice, clean, finished surface on both sides. We're gonna bring the piece of stock over to the saw, and we're going to saw off this stock. So after we saw off our stock, we're going to want to deburr the sharp edges so that we don't cut ourselves. And also we do not want any sharp edges interfering with the clamping of the vise. Another method of deburring the sharp edges off the part is with a hand file, which will take a little bit longer but works just as well. Now we're gonna head over to the machine and power it on by pressing the power on button. Wait a couple seconds for the hot screen to pop up. Release the emergency stop button, press reset and power up restart, and all the axes will home out. First the Z, then the X and Y. After all the axes are homed out, I'm gonna go ahead and position the machine table in a more convenient location, a more accessible location. I'm gonna go ahead and hand jog the X axis until the vise is in the middle of the opening. And this is just for access reasons. It's more convenient. Then we're gonna blow off the vise and make sure everything is nice and clean, that there's no chips or debris that are going to interfere with the clamping of our workpiece. Go ahead and wipe it down. Your vise needs to be absolutely pristine. No deburr, no chips, no anything, because that will interfere with the squaring process. I'm gonna go ahead and grab a parallel, and for the first 3 sides that we cut, we are only going to use one parallel. So we're gonna make sure the parallel is nice and clean. I like to slide it back and forth a little bit. And we're gonna place the back of our stock on top of the parallel. And we're also going to use this bent piece of wire to clamp on the movable jaw. And there is a reasoning behind this, and we can talk about this in class if desired. But we want the fixed back jaw to be completely parallel with the back of that stock. Now we are going to go ahead and put in the 2-inch face mill into the spindle. This is the tool that we are going to be using to square our stock. I'm going to activate hand jog mode. And I'm going to begin to bring my face mill down towards the part. And we are going to position it for the cutting process. I went ahead and turned off the coolant nozzle valve so that we did not have any leaking coolant. And as you can see, there is a marble in this footage instead of the wire. And you can use a marble or a wire, but I tried using the marble at first, but it didn't work out, so I switched over to the wire. But a marble is also a common method used. So I'm gonna slowly hand jog the Z-axis down. We want about 1/8 inch of our face mill over the part in the X-axis. And we're actually going to very slowly plunge our face mill down into the top of our workpiece. So we're gonna get it very close, but not touching yet, because we need to activate the spindle before actually plunging. Now we're gonna activate the spindle. We're gonna go to MDI mode. Erase program, which erases any content that might be in the MDI window. And we are going to type in S1600M3. And you will see the contents in the input field, and we press input and it enters it into the MDI window. When we press cycle start, the machine will execute this code and start the spindle at 1600 RPM. Now we're going to activate 1 thou increments in hand jog mode, and we are going to slowly, very slowly and carefully plunge our face mill into the face of our part until it just skims the workpiece. And then we're gonna stop. Okay, so we hit the top of our workpiece. We're gonna hit the position button. We're going to input Z and press origin, and this is going to zero out our Z axis in our operator coordinate display. Now we can use this as a reference point to set a depth of cut. We're gonna activate the X axis, and we're going to give our face mill clearance. So we're gonna move it away from the part in the X positive direction so that we can plunge down, because we don't wanna plunge down with a face mill into our workpiece. And I'm gonna position it so about 2/3 of my face mill will be cutting along the part. Okay, so now we are going to bring our Z axis down about 5 thousandths, and this is going to set our depth of cut. So we're going to be essentially taking 5 thousandths off the face of our part. And I'm setting that depth of cut with the hand jog wheel. And now we are going to go ahead and take our first cutting pass, first along the X negative direction, then we're going to step over in the Y positive direction and take our last face milling pass in the X positive direction. Now we're going to move up in Y. And then we are going to take our last face milling pass along the X positive direction to finish the face. I'm going to go ahead and blow off the top of the workpiece and take a quick look. And as you can see, only half of the face is finished. The other half is still raw stock, so we need to bring our face mill down even more so that we completely clean up that surface. So I'm gonna bring it down to 12 thousandths total, so an additional 7 thousandths. We're gonna move it back to the starting position in Y, and we are going to go ahead and perform the cutting process once more. And this time it's gonna be sped up. So I'm gonna reset to stop the spindle. Take a quick look. The surface finish looks beautiful. The part completely cleaned up. And now I'm gonna hand jog the tool away from the part in the Z axis to give it some clearance and give us some room to work. Went ahead and took the part out, and now I'm going to deburr any sharp edges that might have formed during that first facing pass. And something I forgot to mention is always make sure that you clean up the largest surface first, which we did. Now we are going to go ahead and put that finished face that we cut last against the fixed jaw in the back. And we're gonna go ahead and clamp it with the wire on the opposite face. And this time we're just resting the workpiece on the bed of the vise, which is perfectly fine. We don't need the parallels because our part has enough width to where our cutting tool can access that face that we are going to cut. Same process as before, we are going to slowly plunge our face mill into the top of the workpiece until it just skims it. And this is going to allow us to set a reference point so that we can set a precise depth of cut. So once it barely skims the surface, you can back it away in X. And now we can go ahead and zero our Z-axis operator display by pressing position, typing in Z, and then pressing origin. And that will zero out our Z-axis operator display, and now we can set a precise depth of cut. And in this case, I decided to go 8 thousandths. So we went ahead and faced it, and that is sped up. We're gonna back the tool away in the Z-axis. And the entire face cleaned up, everything looks beautiful. And we can go ahead and take the part out and file any sharp edges that might have formed during the operation. And now since we have two sides cut, we can go ahead and check the squareness between those two sides by bringing it to a surface plate and using a machinist square. Everything looked nice and square. Now we are going to put the large face that we cut first still against the fixed jaw, and the face that we just previously finished down against the bed of the vise, and still using the wire. Same process, we're gonna plunge our face mill slowly into the face of the part, set a depth of cut, and go ahead and take a facing pass. And keep in mind that we are not making anything to size yet. We are just skimming the surfaces so that we have a nice clean surface finish. We will worry about dimensions later. Now we have 3 finished surfaces, so we can check squareness between those surfaces. And you can also check parallelism with a micrometer, because now we have 2 parallel sides that should be parallel. And you can check parallelism with a micrometer by checking the 4 corners, and you should be getting a very similar reading. Now we can use 2 parallels. So we will no longer be using the wire because we have 3 perfectly square sides. So we're gonna put our 2 finished surfaces against both of the jaws and our large finished face against the parallels. We're gonna clamp it down, and this time we are going to use a dead blow hammer to make sure that it is seated nice and flat against the parallels. And the parallels should not be able to slide if you try to slide them. And this tells you that the part is very square, that those 2 sides are very parallel and also very square to that bottom face. Now we also want to check for thickness, because now we need to bring this part down to thickness. So I got a reading of 1 inch, but we need to get it down to 0.725 inches. So we have 275 thousandths to take off. So we're gonna go ahead and plunge the face mill down into the face of the part so that we can set a reference point for depths of cut. So same thing, position, Z, origin, to zero out our Z-axis operator display. And we are going to be taking 50 thou depths of cut. So Z -50 set with the hand jog wheel. And all of this footage is sped up. Now we are going to drop down to -100 thousandths. Now we are going to drop to -150 thousandths. So the thickness of our part should be about 850 thousandths at this point. We're going to go ahead and drop it down to -200 thousandths. And now we are going to go ahead and check the thickness of our part to see how much material we have left to remove. And I want to leave on 20 thousandths for a finish pass. So I'm going to go down 47 thousandths. And this is leaving on 20 thousandths for a finish pass. And just to be sure, I'm going to check the thickness again, because I don't want to overcut the piece of stock. We don't want to make the thickness undersized or it's scrap. And this time I'm checking with a micrometer for a more accurate, precise measurement. Now I'm going to go ahead and drop it down an additional 22 thousandths and take the finish pass. So that last measurement I must have got a reading of 0.747, because it's supposed to be 0.725. So 0.747 minus 22 thousandths should be 0.725. I'm gonna go ahead and check the workpiece once again just to be sure, and everything looked beautiful. So we have side 1, side 2 that we cut, side 3, and side 4. So now we have 2 sets of parallel sides, and all of these sides should be square to each other. So you can check the squareness with a machinist square on a surface plate. And you should not be able to see a gap between the edge of the machinist square or the workpiece. And then we can also check for parallelism between the 2 larger faces by using a micrometer to check the thickness at each corner. And all these readings should be the same. And this is an easy, convenient way to check parallelism between those 2 surfaces. Now we are going to go ahead and check the thickness of the 2 sides that we have cut previously, because now we need to get those 2 sides down to dimension. So we are worried about the 2.5 inch dimension in this case. So we have already machined these surfaces, but now we're bringing them down to size. We're bringing the width of the part down to 2.5 inches. And I believe this stock is about 3 inches in width, so we have about 1/2 inch to take off. So we are going to go ahead and locate the workpiece against the bed of the vise. Clamp it down nice and tight, and we are going to be taking 50 thou depths of cut. And since we have 1/2 inch left to take off, we have quite a bit of passes to take. So I'm going to go ahead and check the width of this part, this time with a depth mic, because we can't access the bottom surface of the part with a micrometer or a caliper because it's against the bed of the vise. So I'm going to deburr any sharp edges that could possibly interfere with the measurement, and I'm going to use a depth mic and check the distance from the top face down to the bed of the vise, and this will tell me the width of my workpiece. So we went down 450 thousandths, and I'm going to leave on 15 thousandths for a finish pass, so I went down 485 thousandths. So this was a semi-finish pass. And just in case, we want to check it again, because the last thing you want to do is cut a scrapped part. You don't want to cut it undersized. So now we're going to go to the full depth of 1/2 inch and take our final finishing pass. Check it once more just to be sure, and everything looked great. Our next dimension we're worried about is the 3.5 inch dimension, the length of our workpiece. So we're going to go ahead and check it with a pair of calipers to see how much material we have to remove. And we have about 3.560, so we have about 60 thousandths to remove. So these are the two surfaces that we have not even touched yet that are still raw stock. So on the first side, we are going to only skim the surface just to clean it up. And in order to make sure that this workpiece is square to our vise, we're gonna use a machinist square. I'm gonna knock it about 110 degrees counterclockwise, bring in a machinist square, and then I can lightly tap it square to the machinist square with a dead blow. And this will ensure that our workpiece is remaining square to our vise so that all of our sides remain square. So I'm slowly tapping the workpiece until it's perfectly square with the machinist square. And then I'm going to tighten it down. Now keep in mind, the workpiece is not lying on a pair of parallels or the bed of the vise. It's kind of floating. So there's no gap. The workpiece is very square to the vise. And now we're just going to skim this surface. We are not worried about any dimensions yet. We just took off the bare minimum. Everything looked great. Go ahead and deburr the workpiece. And we're gonna take another measurement. And this time we're getting a reading of 3.55. So we took off 10 thousandths and now we have 50 thousandths left to remove. So now we flip it over, and this is the final side we have the machine. So once again, we're gonna use a machinist square to make sure that our stock is nice and square. And you wanna cock the part at about 110 degrees so that you can knock it straight with a mallet. Knock it square with a mallet or a dead blow. So once it's nice and square, you can go ahead and tighten it up. I noticed it was still a little bit off, so I went ahead and knocked it into squareness even more. Everything looks great. And now we are going to go ahead and face mill this part to actual size, 3.5 inches. So I left enough clearance at the bottom to use a caliper to measure it. And now we're gonna go ahead and bring it down to size. So this is the finish pass. And now we should have all of our dimensions pretty much spot on. So 3.5 inches, looks great. This should be 2.5 inches, looks great. And this should be 0.725 inches, looks fantastic.